Listed below are the number of years that archbishops and monarchs in a certain country lived after election or coronation. Treat the values as simple random sample. Use a 0.01 significance level to test the claim that the mean longevity of archbishops is less than the mean for monarchs after coronation. All measurements are in years. Okay, so the first thing I'm going to do is, even though I'm going to use the TI, I'm going to download this to Excel. Okay, that's because I don't want to have to input all the data into the TI. And I'm going to show you what we can do in a couple different ways, but I'm going to show you the way I would recommend you do it. So here's the data. So this is the first step. No matter how you do it, obviously, you got to make sure you have the data. Now, we want to prove that archbishops is less than monarchs. Okay, so remember that our null is always equal. So A and B are just wrong. Don't even have to look at them. Okay, and we want less than, so then we want D. So now the test statistic for the null hypothesis test. So what I'm going to do here is, you could, if you wanted to, you could go to stat, you could go here to edit, and you could put in to list 1 and list 2, or whichever list you wanted, this list of values. I don't want to though, okay? But you could if you wanted to. If you don't want to, like I don't want to, what you would do instead is, here in Excel, I'm going to first find the mean and standard deviation of each of these. So this is A2 through A25, and this is the standard deviation of A2 through A25. And then I'm going to fill right. And then I am going to update this so it's right to 13. I don't think it matters, but it makes me feel better about life. Okay. Now what I'm going to do is I'm going to use these values. So I'm going to come here and I'm going to make sure, actually, before I do anything else. Okay. I wanted to make sure I wasn't missing any decimal places. I'm going to go to stat. I'm going to go to tests, and I'm going to go right here to sample t-test. Okay, so just like before, but now instead of using data, I'm going to use stats, and I'm going to put in these numbers I just got. So 12.87. Well, it helps. 12.875. 4.5997. And again, how many decimal places you keep is up to you. And then I had, let's see here, 24. And then 16.5.7838. And I have 12. Okay. Then I do want less than right here. Okay. Pooled, no. Calculate. So then my test statistic right here is negative 3.3, I think 2 decimal places, so 39. Yep. Okay, now my decision. So I can do this two ways. I could get a critical value and compare it, or I could use this p-value. This p-value is less than my significance level of 0.01 by a far. That's scientific notation. This is 0.0009. Well under. So then I would reject. I do have sufficient evidence to support the claim that archbishops have lower longevity than monarchs. The other way would have been to find the critical value. So I would have went over, and actually I would have went to second var, so I would have went to the distribution menu. I want my inverse t. My area is 0.01, okay, because it's all in one area. It's a one-tailed, so I don't have to divide it by 2. My DF, I would use the smaller, so in this case that's 11, and paste. And I get negative 2.72. My value of negative 3.39 falls in then the tail. It is smaller. Since less than, you want smaller, so I would reject. So either way works. Okay, so that's part A. Now from part B, I want to go here and I want to find the confidence interval. So I'm going to do the same thing. I'm going to go to stat. I'm going to go over to tests, and I'm going to go down here to, I'm flipping down here. I want the 2 sample t interval. Okay. So now I'm going to do the same thing, stats. I'm going to put in my values, which it transferred from my hypothesis test, but if not, put them in here. Okay. And then now, what is this? So I had a 0.01 significance. That means each tail had 0.01. To make this confidence interval match my one-sided test, remember I double it, so I'm actually going to do a 98% confidence interval so that I have 0.01 in each tail which match the decision I made earlier. Polled is no, and I'm going to calculate. So then up here, this -6 years to -1 year, that is my interval. So I'm going to come down here, and it said 3 decimal places, so 244, -1.006. Okay, and does it match? Well, yes, because it contains only negative values, so less than I'd want negative. Okay, if it was a greater than I'd want all positive, but it doesn't contain 0, right? That's my main thing I'm looking for. It doesn't contain 0, which would mean a reject. In this case, they're negative, so it concludes less than. So hopefully this helps you. You certainly, as I mentioned, could have input all your data in by here and done it that way. I just simply find it a lot easier to let Excel do the first couple of steps and find the mean and standard deviation and plug those in that way because then I don't have to transcribe any data. And I don't like to transcribe data, A, because it's tedious, but B, because I make mistakes. So I would recommend that if you're using your TI here, I would let Excel do this first step, which you can do without the data analysis tool, and have it do that and then plug it into your TI that way.